Now that we have a rather flexible way to find the solutions to quadratics, we might turn the problem around and say, if we know the solutions, can we find an equation that has those solutions? Let's start with something that we usually see in a quadratic. Sometimes we see something like this, that x equals 2 or x equals -3. Now, where do these come from? They come from factors. So if x equals 2 is my solution, what was the factor that gave it to me? X minus 2. And if x equals -3, what was the factor that gave that to me? X plus 3. Now, if we set this equal to 0, we have an equation whose answers are 2 or -3. If we multiply this back out using FOIL, x squared plus x minus 6, when we combine the middle terms, we'll have a quadratic equation in standard form that has the solutions we require. This is not the only quadratic equation with these answers, but it is one, and if that's what we're trying to do, is find an equation that has these solutions. Let's try it with a little more complicated set of answers. These are just nice rational number answers. What if they were irrational? Suppose x was equal to 1 plus the square root of 2 or 1 minus the square root of 2. Then what would the factors be? Well, we'd have x minus 1 plus the square root of 2 and x minus 1 minus the square root of 2. Now, inside these larger parentheses, that is, the full factor parentheses, here and here, we could rearrange these using the associativity property if we distribute the negative signs. Let's show you what I mean. I'm going to say this is x minus 1 minus the square root of 2. And this is x minus 1 plus the square root of 2. I've removed the parentheses. Well, actually, what I'm going to do now is put parentheses back in, so I'm going to regroup them, and I'm going to do that this way. I'm going to say that's x minus 1, and I'm going to see that that's also x minus 1. Now, if you look carefully, I've got something minus radical 2, and the same thing plus radical 2, so I have the sum and difference of two binomials. A little more complicated than we usually see it, but that's what it is, the sum and difference. So when I multiply these together, I'm going to get the difference of two squares. That is, I'm going to have x minus 1 squared, and then negative square root of 2 times positive square root of 2 is minus 2. And all this is going to be equal to 0. And when I get this operator taken care of, x squared minus 2x plus 1 minus 2 equals 0, I'll find that I have x squared minus 2x minus 1 equals 0 as my desired equation. Let's look at that again. We took the two solutions and we wrote them with parentheses into factors. Then we removed the parentheses and regrouped them so that there was x minus 1 in both and a plus and a minus for the second term, which was the square root of 2. That gave us the difference of two squares. And when we expanded and combined terms, we got our solution.